Hello children, today's topic is laws of exponents for real numbers. In our previous class, means in class 8, we have learned few laws of exponents. Okay, so let us just recall. So the first law of exponent, a raised to the power m multiplied by a raised to the power n. If base is same and multiplication sign in between, then we can add the powers. So we'll get a raised to the power m plus n. Second, a raised to the power m whole power n. Power then one more power. So we can write a raised to the power mn. We'll multiply the powers. Third, a raised to the power m divided by a raised to the power n. Same base and division sign, so we'll subtract the powers. So we'll get a raised to the power m minus n. And here there is one condition, this m is greater than n. Means power of this term is greater than power of this one. Okay. And the next one is a raised to the power m and b raised to the power m. Two different bases and same power, so we can write a be the whole power m. Okay, or one more, we have a raised to the power m upon b raised to the power m. Different bases but same power, so we can write a by b the whole power m. We also know that a raised to the power 0, any term raised to the power 0 is 1. Okay, and also if it is written 1 upon a raised to the power n, then this can also be written as a raised to the power minus n. Okay, so we have already used these laws of exponents, but now we will use these laws of exponents when the power is a rational number. For example, how will you simplify this? 2 raised to the power 2 by 3 multiplied by 2 raised to the power 1 by 3. Okay. So when you observe, you will find that we can extend this laws of exponents that we have studied in earlier class. So we can extend these laws of exponents for rational number also. Okay. So let us try to simplify this one. So same base and multiplication sign. So 2 raised to the powers, we'll add the powers simply. 2 raised to the power 2 by 3 plus 1 by 3. So now we will add 2 by 3 and 1 by 3. Same base, same denominator. So 3 will be the LCM and 2 plus 1. So 3 by 3 means 2 raised to the power 3 by 3 means 2 raised to the power 1, which is nothing but 2. Okay. So if you know these laws of exponents, you can solve the next exercise very easily. Okay. So now the next important thing is, we have already discussed square root of a number. So if square root of 5 means 5 raised to the power 1 by 2. Square root means power 1 by 2. If it is cubic root, then power 1 by 3. Okay, so in general, nth root of a number is 5 raised to the power 1 by n. Okay, so this is our next law. Nth root of any number, it means a is equals to 1 by n. Okay, and one more, from here we can say, if here a raised to the power 1 by n, it means nth root of a. If a raised to the power m upon n, then how to write? So see, a raised to the power m by n, this can also be written as a raised to the power m multiplied by 1 by n. Okay, or a raised to the power 1 by n raised to the power m. We know that a raised to the power m multiplied by n is nothing but a raised to the power m n. Okay, so we'll use this result here. So a raised to the power m multiplied by 1 by n can also be written as a raised to the power 1 by n whole power m. And just now we have seen that a raised to the power 1 by n is nth root of a. It means this can also be written as nth root of a and whole power m. Okay, so whenever you find like this a raised to the power m by n, this can be written as this. For this 1 by n, we'll get nth root and power m. Okay, so now on the basis of these laws of exponents, we'll solve our next exercise, exercise 1.6, which is very simple but very important. Okay, exercise 1.6, question number 1 is find. There are 3 questions in question number 1. There are 3 parts of question number 1. We'll solve all the questions. So still, if you are not able to, if you find any difficulty in laws of exponents, it's completely fine. You just see these examples. From this example, you will understand the laws of exponents. Okay. So the first question is 64 raised to the power 1 by 2. We have to simplify. We have to find this value. Okay. Or we have to write our answer in the simplest form. Okay. Just simplify. So in the solution, see this 64 can be written as square of 8. 64 can be written as 8 square. Okay, this you know, because in class 8 we have studied square and square root, cube and cube root. And if you don't know, still you can find the square root of any number. Okay, so 64 is a square of 8. So this, at the place of 64 we can write 8 square, and we have one more power 1 by 2. Now by using the identity a raised to the power m raised to the power n, power then power. So this can be written as a raised to the power mn. Okay, we can multiply the power in the simplest way. One base in 2 powers, then we can multiply the powers. So we'll get 8 raised to the power 2 multiplied by 1 by 2. This 2 and 2 will cancel out. So 8 raised to the power 1, which is equals to 8. So this is the answer. Okay. Now the next question is 32 raised to the power 1 by 5. 32 raised to the power 1 by 5. 1 by 5. Now this 32 is not a perfect square. Okay, because square of 5 is 25 and square of 6 is 36. Okay, and this 32 lies between 25 and 36. So we will find the factors. So 32 will find the factors, will divide prime factorization method. 2 1s are 2, 2 6 are 12, 2 8s are 16, 2 4s are 8, 2 2s are 4 and 2 1s are 2. So this 32 can be written as 1, 2, 3, 4, 5, 2 raised to the power 5. So 32 can be written as, this 32 can be written as 2 raised to the power 5 and this 1 by 5. Again by using the same laws of exponent, a raised to the power m raised to the power n is equals to a raised to the power mn. We'll use this law here. So 2 raised to the power 5 multiplied by 1 by 5, and 5 will cancel out. So 2 raised to the power 1, it means 2. So the answer is 2. Okay. And the next one is 125 raised to the power 1 by 3. So now I want you to solve this one. Okay, you just solve this one and just check whether the answer is correct or not. So let's move to the second question. So this is for homework. Now question number 2 is, again the question is same, find, and there are 4 parts in this question, 4 questions in this question. So the first one is 9 raised to the power 3 by 2. 9 raised to the power 3 by 2. We'll repeat the same process. This 9 is a square of 3. Okay. So 9 can be written as 3 square, power and then power. So power and then power, it means we will multiply the powers. So this can be written as 3 raised to the power 2 multiplied by 3 by 2. This 2 and 2 will cancel out. So 3 raised to the power 3. And 3 raised to the power 3 means 3 multiplied by 3 multiplied by 3, which is equals to 27. So the answer is 27. Okay. Now see the second part of this question. Second part is 32 raised to the power 2 by 5. 32 raised to the power 2 by 5. Just now in the previous question, means in question number 1, second part, we have seen that 32 can be written as 2 raised to the power 5. So at the place of 32, we can write 2 raised to the power 5, 2 raised to the power 5 and then whole power 2 by 5. Again by using the same identity, a raised to the power and then one more power. So this can be written as a raised to the power mn. So this can be written as 2 raised to the power 5 multiplied by 2 by 5. This 5 and 5 will cancel out. So we will get 2 raised to the power 2. 2 raised to the power 2 means 2 multiplied by 2, which is 4. So 4 is the answer. Okay. Now third part of this question is 16 raised to the power 3 by 4. 16 raised to the power 3 by 4. So now I want you to solve this one. Okay. So this is for homework. And fourth part I will solve 125 raised to the power minus 1 by 3. Okay. Here power is minus 1 by 3. And we know that this 125 is a cube of 5. Okay. Means 5 cube is 125. So at the place of 125 we can write 5 cube. So 5 cube then whole power minus 1 by 3. So 5 multiplied by 5 raised to the power 3 multiplied by minus 1 by 3. 3 and 3 will cancel out. So we'll get 5 raised to the power minus 1. This is nothing but 5 inverse, means 1 by 5. So the answer is 1 by 5. Okay. Now let us see question number 3. Question number 3 is simplify. And again there are 4 parts. So the first part is 2 raised to the power 2 by 3 multiplied by 2 raised to the power 1 by 5. Okay, now we have to simplify. So here when you observe, you will find that 2 is the base, common base, and multiplication sign. So by using this laws of exponent, a raised to the power m multiplied by a raised to the power n. Same base a and multiplication sign. Same base and multiplication sign, so we can add the powers. So we will get 2 raised to the power. You need to mention whenever you use any identity, just within bracket mention by using this identity. Okay. So 2 raised to the power, we will add the power 2 by 3 plus 1 by 3. Okay. Now we will take LCM here. So LCM is 3 and 2 plus 1 is 3. So 2 raised to the power 3 by 3 and 3 and 3 will cancel out. 2 raised to the power 1, which is equals to 2. So the answer is 2. Okay. Now let us see the next one. Second part of this question. 1 divided by 3 raised to the power 3 and the whole power 7. Okay. So in the solution, what we can do? See, the whole power 7 means power of numerator and power of denominator. We can write this 7 as a power of numerator and power of denominator simply by using this law a by b the whole power m. It means a raised to the power m and b is also raised to the power m. Okay. Numerator, denominator, whole power. So power of numerator and power of denominator. So we can write 1 raised to the power 7 and here 3 cube raised to the power 7. 1 raised to the power any term is 1 only, and here by using the law a raised to the power m raised to the power n, power then a raised to the power mn. So we'll get 3 raised to the power 21. Okay, so answer is 1 by 3 raised to the power 20. Or if you want, you can also write it as we have seen in the previous question. If it is 1 raised to the power 5, then this can be written as 5 raised to the power minus 1, means 1 raised to the 1 divided by 5 raised to the power 1. So 5 raised to the power minus 1. Or 1 divided by 2 raised to the power minus 2. So this can be written as 2 raised to the power 3. Or 1 by 2 raised to the power 3, then we can write 2 raised to the power minus 3. So whenever we change, so the sign will change, okay. So here we will get 3 raised to the power minus 21, okay. So this is the answer. And in the first question, it's 5 not 3, okay. Here I have taken 3. So in question I'll make change first and I will solve this question number 1 once again. So here I have written 3. So for if it is 3, then this is correct, but the question is actually 2 raised to the power 2 by 3 multiplied by 2 raised to the power 1 by 5. I thought it's 3 only. So it's again same base, different power and multiplication sign. So we can add the power. So 2 by 3 plus 1 by 5. So 2 raised to the power will take LCM. LCM is 15. Then here we'll get 10 plus 3. So we'll get 2 raised to the power 13 by 15. This is the answer. So please correct it. It is 1 by 5, not 1 by 3. I read 1 by 3 and I have solved by taking 1 by 3 only. So please make a change. So first we have done, second we have done. Let us see the third one. It is 11 raised to the power 1 by 2 divided by 11 raised to the power 1 by 4. Okay, so now you have to think which identity, which law we can use here, and it takes time, okay. You need to practice a lot. Generally the question arises, how do we come to know which identity, which law we have to use here? So the only answer is, the only way is practice, okay. Through practice only we can say that, means you will, once you will practice enough, you will easily find which identity, which law we have to use here to simplify, okay. So this is same as a raised to the power m divided by a raised to the power n. See, same base and different power. So a raised to the power m divided a same base 11 same base and different power m and different power 1 by 2 and 1 by 4. So same base, different powers and division sign. So we will subtract the powers. Okay. So we'll use this law here. So we'll get 11 raised to the power 1 by 2 minus 1 by 4. Okay, 11 raised to the power. If you want, you can put this bracket, or if you don't put, then it's fine. So 11 raised to the power will take LCM. LCM is 4 and we'll get 2 minus 1 and 2 minus 1 is 1. So 1 by 4. 11 raised to the power 1 by 4 is the answer. Okay. Now the last question of this chapter and this exercise is 7 raised to the power 1 by 2 multiplied by 8 raised to the power 1 by 2. Now let us identify which law we can use here. See, the power is same and the base is different. It means it is like a raised to the power m. Power is same, base different. So combined power we can write a b raised to the power m. So we can write in the solution 7 multiplied by 8 raised to the power 1 by 2. Okay. So this is nothing but 56 raised to the power 1 by 2. But we always need to write our answer in the simplest form. So what we will do, we'll just check whether 56 is a perfect square, or this 56 can be also be written as, we'll find the factors. Okay. So 2 2s are 4, 2 8s are 16, 2 1s are 2, 2 4s are 8, 2 7s are 14 and 7 1s are. So it's not a perfect square. Okay. So this is the only answer. Or see, we have already done the chapter square and square root, cube and cube root. So even there is no need to find Okay, we know that 56 is not a perfect square. Okay, but if you don't know, you can find like this. Okay, I have done here so that you will understand how to find whether it's a perfect square or not. Okay, so this is the answer. But in NCRT very few questions are given. We will also solve some extra questions. So you just practice these questions first, and in the next class we will discuss few more questions. Okay.